Hi, morning, everybody. Today we're going to be going over notes 10.1, graphing square root functions. So we are moving away from Unit 11 just for a little bit, just to get us started with this concept of roots. One other thing that we said about a square root, don't forget, a square root means we're talking about this symbol here. We've talked about how to get rid of it. We use powers of two when we're solving with a square root, but that's not the goal for today. Today we're going to talk about what do these graphs look like, right? So far we've drawn lines. So that means it has a power of one that's invisible. We've drawn absolute values in this class. Looks like a V shape, but an absolute value has the absolute value symbol, right? These two lines that represent an absolute value. We've also, one of our other big graphs has been y is equal to x squared, a quadratic. So that's a parabola, takes that U shape there. And that's when we finally started to curve, no jagged edges. And then, of course, the other one that we've done is y is equal to, just as an example, let's talk about an exponential function, like let's say 2 to the x. And that's where, of course, we had an asymptote. And then we had a plane, it looked like a plane taking off, or it could have been a plane landing. But we've talked about exponentials as well. So we've worked with light, absolute values, quadratics, right? A parabola, and exponential functions. Well, today we're going to talk about how do we draw this type of graph? It's called the square root. Remember, there is an invisible 2 here. So we are definitely going to use the calculator today to do this. So this is a warm up here just to get the idea across. It says make a table of values for each function. Use the table to sketch the graph. Describe the domain of the function. Describe the range. So it says y is equal to square root of x. So here, this is what we call the most basic square root function. It is the parent function. This is what all square roots are going to follow here. So here's what we want to do. We're going to create a table. So we're going to try to see if we could keep the same numbers for all of them, -2, -1, 0, 1, 2, 3, and then the calculator is going to do most of the work for us. So have a calculator handy. Now, if you use Desmos Scientific, it will be a lot easier because you know you can type those numbers in very quickly. All right, so remember, it says square root. So here's what I'm going to set up on Desmos. I'm going to write the square root, and then I'm going to plug in a -2. That's what I'm going to put in there. For the other, I'm going to go square root. I'm going to put a -1. Put that in there. This one right here, it says square root. So square root, I'm going to put in a 0. And I think you get the idea now. So let's see. Let's try it out. So square root of -2. Notice the calculator says error. I know your calculator might say domain issue. So that means that when I get a square root, this is not possible. So I'm just going to cross it out. All right, well, let me try a -1. So I'm going to do a square root of -1. And again, look, we're getting an error. All right, so then I'm going to cross this one out too. I'm not getting any info for these. So I go square root of 0, 0. Let me start all over. Square root of 0. Here we go. All right, I finally got a number. I got an answer of 0. So now I'm going to plug in a 1. So I'm going to go square root of 1. All right, I got 1. I'm going to take a square root of 2. All right, I got 1.4. We're graphing, so just make sure you cut it off at 1 decimal at least. So we got 1.4, and then I'm going to do the square root of 3. So the number did get bigger. Notice it's not dropping. So 1.7. And you know what? Let me see what would happen if I did one more number. Let me add one more number to the list. I'm going to put a 4 there, and then I do the square root of 4. Well, remember, we know the square root of 4 works. It's on our list of numbers, so we got a 2 for it. All right, well, I'm ready to draw it. So I'm not going to be able to draw anything at -2. I'm not going to draw anything at -1. But at 0, it says your first point is 0, 0. All right, let me draw that in. There's 0, 0. Next one is 1, 1. 1, 1. Now the next one is 2, and then just over the 1. The next one at 3 is 3. So there's the 3. And then just a little higher, so just under the 2. And then at 4, it's a full 2. And so if you notice, this graph does not exist on this side of the graph at all. It's also never going to come back down. Notice the numbers just keep very slowly getting bigger and bigger, but at a very slow rate. So here it is for the first time, maybe for some of you. Here is the graph of a square root. The square root starts at 0, 0, and then it very slowly just climbs up and up and up, and it's never going to come back down. So you have to make sure that it's slanted, increasing, going up forever. So that's why when they talk about talk about the domain and the range. Well, my domain is I can't have a graph. I can't take square roots of negatives. Look at that. None of these worked. So square roots of negatives are not allowed. I can take the square root of 0. I can take the square root of any positive number. And because I can only work with positive numbers, notice how my graph is on top of the x-axis as well. So there's a lot of information here that we can get. But again, from the looks of it, here's the big thing we need to remember that we're getting from this. We cannot take square roots of negatives. So we cannot take the square root of negative numbers. That's the big thing to get from this. Now, most of the work is going to be done by the calculator. I just needed you to see that if it does say error or domain or something, just cross it out. It means you can't do anything with that value. So negatives, we cannot work with negatives. Now, we still plug them in. That's what you have to understand. We still plug them in. It just didn't work for the parent function, but every function is a little different. So if this is what most of our graphs are going to look like, well, then let's do a little practice because we know they're going to mess with them a little bit. So it says a square root function is a function that contains a square root, well, yeah, of course, with the independent variable in the radicand. The parent function for the family of square roots is y equals the square root of x. So that's what they mean by the independent variable. X is in the radicand, is inside, right? So that's what they mean. When you get an x on the inside, this is what our graphs tend to look like. And look at the points. There's 0, 0. There's 1, 1. There's 4, 2. Now, there is another one that works out nicely. Look at the 9. What's the square root of 9? Well, the square root of 9 is right there. That's why it's on our list of numbers, but these would be the points that work out nicely. And we know that list just keeps getting bigger and bigger, so that's why it keeps rising very slowly, but it keeps rising. So, like I said, the main thing today is the calculator will do most of the work for us. So, let's see. Now, for this example, this last example on this page at least, it says graph y is equal to the negative square root of x. So, yeah, I'm going to go with the same points, negative 2, negative 1, 0, 1, 2, 3. All right, now remember, when you plug into your calculator, here's what you're going to put on the calculator. You're going to write the negative. You're going to write the radical. And then it's going to probably put a parentheses. Well, this is where you're going to plug in all of these numbers. The numbers you plug in are the ones that go there in the yellow. And these are the numbers we're going to throw in there. But again, you got to type in that negative first. So negative, then the square root, and you see there's my parentheses ready to go for all these numbers. Now, we already know what's going to happen here. Look, you could type in that negative 2, but we already said I can't take the square roots of negatives. So if I can't take the square root of negatives, the sooner I learn that, the sooner I can just do this and go, okay, no negatives. All right, I'm going to throw in a 0. So negative radical 0 is still 0. This is all on my calculator. The square root of negative square root of 1. Well, we already know the square root of 1 is 1, but because there's a negative in front, then it's going to have a negative in front. So again, as you're typing these into your calculator, don't forget that you have to have that negative there. Now, if you notice, these are the same numbers from earlier. So it's just going to be negative 1.4 on the calculator and negative 1.7. It's the exact same numbers that we did on top. All I have to do is, according to this, is put a negative in front of it. So the question is, well, okay, so what does a negative do to my graph? Well, let's find out. First point is 0, 0. Okay, there it is, 0, 0. The next point is 1, but negative 1. 1, but it's negative 1. 2, negative 1.4. 2, you go to negative 1, but then you got to go a little bit more, or a little lower in this case. Then it's 3, and then negative 1, 7. And remember, if we had added one more point, that would be a 4 and a negative 2 from earlier. So 4 and negative 2. So when you get a negative in front, we call that a reflection in math. And it's a reflection because it basically the same graph we did on the top. Actually, you can see it right here. It's the same graph, but because there's a negative in front, it was reflected on the x-axis. Think of it as being flipped over this way, which is what we did. We flipped it over, and that's why it's at the bottom. So that's what a negative is doing to our graph. It's making a reflection of it. But again, the calculator does all the work. You just very carefully have to know how to draw your points. And again, if your graphs don't look like this, what I'm pointing at up here, if you look up for a moment, or if they look like this because of the negative, well, then we know something went wrong. They have to look like this if there's a square root involved. In fact, look, they're going to test this a little bit more on the next one. So when you look at the next page, look, now they're starting to add numbers on the inside. Well, that's okay. Look, here we go. I'm going to go with my classic, like I already said. We're going to go with negative 2, negative 1, 0, 1, 2, 3. All right, now remember, on my calculator, here's what I'm going to type in. Square root, and yes, I'm going to have a parentheses, but I need to write in my number plus 2. See, you're going to be plugging in here. You got to make sure that plus 2 is inside. You're going to plug these numbers in right there. But that 2 needs to be inside of that parentheses. That's why Desmos is better. Desmos will make it look like this. It is a lot better with Desmos. So, all right, let's see. Here we go. Square root. I'm going to plug in the first number, negative 2, negative 2. I'm going to put plus 2. So plus 2. And then I'll close my parentheses. Remember, this is the number that I'm going to be changing, that very first one. I'm going to keep changing that one over and over. Hit enter, and look, I got 0. Okay, so see, a negative actually worked this time. That's why you have to test it out. You can't say, oh, he said no to negatives. No, no, no. As soon as they start adding numbers, we have to change that idea. All right, so now I'm going to put in a negative 1. So let me go back up there and change that to a negative 1. Hit enter. Look, I got an answer of 1. I'm going to go back up there, and now I'm going to plug in no more negative. Now it's just a 0. So I'll plug in a 0 there. See, it says 0 plus 2. All right, look at those numbers. They tend to start looking the same, 1.4. Look, if I remember the last one, I think it's going to be a 1.7. So let's find out. Plug in a 1. Yep, 1.7. I'm going to go in there and plug in a 2, but that's a great thing. You just go back up and change it. Plug in a 2. I got a 2 as an answer. And I still have one more box, so I might as well just go up there. Remember, Desmos Scientific. You could do this very easily as well. Plug in a 3, and there you go, 2.2. And again, we are graphing, so don't worry so much about the rounding since we're just trying to draw this thing. All right, so we're ready. Negative 2, 0. So look, it looks like they shifted the graph over. Negative 1, up 1. Negative 1, up 1. 0, 1.4 means just over the 1. 1, there's the 1. And then up 1.7, so just under the 2. Then we've got the 0.22. That one works nicely. 2, there it is. And then the other one is 3, and then just over the 2. Remember, they should always look the same. And they rise very slowly. Some people do this and then they make them shoot up really quick. No, no, no. They keep rising. They do go up forever, but at a very slow rate. All right, so there's the graph of our function. And again, the calculator's doing most of the work. You just have to be careful with how to plug it in. So when we look at number 3, look at the big difference. You might say, oh, number 2 and number 3 are exactly the same. They're not. Look at the location of the 2. The 2 was on the inside. Here, for number 3, the 2 is on the outside. So we're going to see what a number on the outside does. So the number on the inside, move my graph to the left. So now let's see what a number on the outside will do to it. So we're going to do with our classic 3 points, or sorry, classic 1, 2, 3, 4, 6 points there. All right, here we go. We're going to try -2, -1, 0, 1, 2, 3. But we have to be very careful. This 2 cannot be inside the radical. So on your calculator, you're going to go like this. It's going to start a parentheses. Well, you need to close it right away because that +2 better not be in a parentheses there like it was earlier. Earlier, it needed to be in there. So not this time. I'm plugging in right here. These are the numbers that I'm going to put in there. But notice, pay attention to this. The 2 was in the parentheses inside with it. It can't be inside here. That 2 needs to be outside this radical, so you close the parentheses up. So, all right, so here we go again. Let me just start fresh. Let me delete that. So I go square root. First number is -2. I'm going to close the parentheses, and then I'm going to press +2. Now, I'm getting an error message. Okay, remember, we don't freak out about that. That just means I'm not going to get a number for this one, so I cross it out. And then I go back. So it says go to, press the arrows, okay? So now I'm going to change that to a -1. -1, I hit enter. Look at that, error again, okay? We don't freak out. All that means is I don't have a number for that one, so I cross it out. All right, I'm going to throw a 0. So all you have to do is press the arrows, and look at that. It takes you right back. There's the 0. All right, I got an answer of 2. I'm just filling out the table as I go. All right, let's see. Next number is a 1, so throw in a 1. We've got a 3 as a result. So we got a 3 for that one. Let's keep going. Remember, let the calculator do the work. Don't spend so much time thinking about it. Just make sure you're typing it in correctly. All right, now I got 3.4. So 3.4. And the last one I'm typing in is a 3. So here we go. Type in a 3. And there you go, 3.7. They really use that 0.4 and the 0.7 a lot, if you notice the pattern. So look at the big difference. Even though you might say, oh, these are the same, they're not. A 2 on the outside, look at these numbers. A 2 on the inside, numbers are very different there. So let's draw it out. So here we go. All right, none of these numbers work. All right, that's less points for me. 0, 2. 0, I go up 2. 1, so I go 1, and then I go up to 3. So I go up to 3. At 2, I go up to 3, but then I go a little bit over because it's 3.4. At 3, I go up to 3 again, but then I need to go even just a little higher because of the 3.7. And then there it is. Remember, do not make it look like it's dipping back down. It's not. It's raising and increasing forever and ever. But there's our graph. So notice the big difference. When you have a number on the inside, that created a move to the left. So maybe it could also move to the right if there's a number on the inside. But when you have a number on the outside, it actually shifted our graph up in this situation. So depending on what numbers and where they put them, it will have an effect on our graph. But for now, we're just trying to get an understanding, but that's why tables are our go-to. When you don't know what a graph looks like, you make a table in math and then let the calculator and every tool you have available help you out. All right, so now let's look at this one. Oh, look at this. Now they're going to throw a number right next to it. Remember, that's multiplication. So I'm still going to go with my usual, -2, -1, 0, 1, 2, 3, just as some classic points to work with. All right, but here's what I'm going to put in my calculator. I'm going to write the 2 instantly. I'm going to write a square root, and then that's it. So all my numbers are going to go in here. That's where these numbers are going to go. That's where we're going to plug in. All right, let's go. Let's get the calculator ready. Type it in. 2 square root. All right, -2 first. I think we already know the answer there, though, because I'm not adding or subtracting. So, yeah, I figured. Error. There's no answer on that one. Look, -1. You already saw that earlier. You could type it in, but I'll tell you right now, that's going to be an error message too. If you don't believe it, well, here we go. -1, there's your error message. All right, I go back. I'm going to turn it into a 0. So I've got 0. I'm going to go and plug in a 1 now. So plug in your 1, and you get an answer of 2. Okay, so an answer of 2. I'm going to go back, and I'm going to put a 2 in there. 2.8. So 2.8. And then I'm going to go in there and then type in a 3. So 3.4. And you might be saying, shouldn't you round it? Yeah, go for it. Round it off. Or just call it 3.4. Or call it 3.5 just to make it official. But even if you wrote 3.4, that's still really close, right? We're just graphing. We just want to get an idea of where to draw this. So again, I'm not going to use the -2. I'm not going to use the -1. The first point is 0, 0. There it is, 0, 0. The next point is 1, 1. But then I go up to 2. So notice it's almost like they're stretching it out. The next one is 2. And then I go to 2.8. So just under the 3 mark. And then 3. And then I go up to 3.5. So 3.5. So kind of halfway through. But you see, there it is. It is rising. Remember, slowly. You don't make it shoot up all of a sudden. It very slowly rises. But this one looked like it got stretched out compared to our last problem. It looks like they stretched out the graph because instead of being 1, 1, it went up to 1, 2. Again, just be very careful with the way you type it in to your calculator. So that's why we look at this one now. Look, very last one. We got to be careful with our calculator. Here come my usual numbers. -2, -1, 0, 1, 2, 3. So here's how you type it into your calculator. You have to look carefully. There's the square root. Remember, the calculator is going to open a parentheses. But notice how that -2 right here, this -2 needs to be with the x. So then I'm going to write a -2, and then I have to close the parentheses because that 4 is on the outside. So then I'm going to say +4. Where you're going to plug in these numbers is right here. This is where the number is going to go. So again, look carefully at how you're going to type it into your calculator. That's very important. That 2 is inside. Then you need to make sure you close the parentheses after the -2. That +4 is on the outside. Make sure it's not part of the parentheses. And so now, let me get my calculator ready. All right, here we go. Let's see. Square root. I'm going to start with -2 first. So -2. Careful there. Square root. I'm going to start with the -2, and then it says -2. -2. Close the parentheses, and then I'm going to type in +4. Again, very important that you're closing a parentheses today. All right, let's see what happens. Error. No answer for this one. All right, let's cross it out. No answer there. Let's keep it going. Now I'm going to change. Remember, we're only changing this -2, not that one. Everything else stays the same. So now I'm going to change it to -1. Let's see. Still an error. Okay, still not working for me. Now I'm going to change that -1. Again, look up if you need to. We're going to change that -1 to a 0. All right, let's see. Put in a 0. Wow, still no answer. All right, we'll just keep crossing them out as we go. And now we're going to change that 0 to a 1. Ooh, still no answer either. All right, what's going on here? We might have to pick a couple more numbers to get a better idea. Let's see what happens. This hasn't happened yet. Now I'm going to plug in a 2. So plug in a 2. There we go. Now we have a first number. So our first number is actually 2, 4. So that's where our graph is going to begin, right? If you notice, that's been the pattern. Didn't work. Look at number 4, example 4. That didn't work. That didn't work. That was the beginning, 0, 0. Well, for this one, this is where my graph starts. Now I'm going to plug in a 3. All right, let's see. Delete, put in a 3. All right, I got an answer of 5. So my table is done, and you might say, I don't think that's enough points. Remember, you can always add more, right? You can make more points if you need them. But if you already know what the graph looks like, we really just needed to have our starting point. And this is where it starts at 2, 4. So I go to 2, I go to 4. There's my first dot. Then it says go to 3. So go to 3, and then I go up to 5. So there's my second dot. And again, if you need more points, we'll plug in a couple more to get an idea. But honestly, if you already know that all your graphs always look like this, and they always look like that, well, then I can already get an idea of what it looks like and draw it. They always look the same for a square root. So you could draw more points if you need them, but you can already start drawing this as well. So this is what square roots look like. It is our last graph of the year. Notice how it comes right at the end. One of these questions will be on your test, so we do need you to practice. And that is why when you flip your page, your classwork is only 4 little problems where you're going to practice that. And then you'll start with the assignment, the homework assignment, which is more practice for next week's test. So take your time, get your calculator going, and if you look carefully, you better close that parentheses for this one. That 4 is on the outside. It shouldn't be in there. With that said, have a wonderful day, everybody. Get to work. Don't fall behind on us.